Welcome to today's deep dive. We've put together a pretty custom mission for you today.
Yeah, it's a fascinating one. We are figuring out how a tech company survives and, actually expands when the global hardware market is literally splitting in two.
Right, think about building like a massive blockbuster video game.
Oh yeah, the video game analogy is perfect for this.
Yeah, because usually you just want to put it on a disc and have it run seamlessly on a standard PlayStation anywhere in the world, right?
Exactly.
But imagine having to build that global blockbuster while simultaneously rewriting it from scratch to run on a completely custom homemade console that only exists in one single country.
And that is the exact logistical nightmare that Moonshot AI is navigating right now with their new AI model, Kimi K3.
Yeah.
I mean, they are caught right in the middle of this huge, high-stakes geopolitical chess match over AI microchips.
Okay, let's unpack this. Moonshot is surviving this divide using what they call a dual track strategy.
Right, so to capture the global developer market, that first track has to play nice with the world's existing compute infrastructure.
Which is, overwhelmingly dominated by NVIDIA.
Overwhelmingly. So they optimized K3 using NVIDIA's standard software platforms like CGA and Triton.
Right.
This basically means any enterprise that's already running legacy H100 or H200 clusters can deploy K3 with, like, a one-click integration.
So that covers the global PlayStation side of things.
Exactly.
But Moonshot is a Chinese company, and their domestic enterprise clients face some pretty strict hardware import limits. They can't just order a warehouse full of NVIDIA chips.
Which brings us to the domestic track. To bypass those import restrictions, K3 has to run natively on local Chinese software stacks.
Like Huawei's CAN architecture, right?
Yep, exactly. And the way they bridge that gap is just staggering. I mean, usually entire teams of human engineers spend years building a compiler.
Which is essentially a complex translation dictionary to make the software work on a new chip.
Right. But K3 autonomously developed its own custom compiler. They call it Mini-Triton, to translate standard operations into local machine code.
Wait, really? The AI model essentially learned the grammar of Huawei's hardware and just wrote its own translation software to bypass the physical hardware limits?
Yeah, it did it itself.
That is incredible. But, K3's ability to adapt like that completely undermines the U.S. strategy of starving them of hardware.
It really does.
If the software can just rewrite itself for any domestic chip. So what does this all mean? Why doesn't the U.S. just slam the door completely and enforce a 100% airtight physical embargo on all GPUs to stop this?
Well, what's fascinating here is an absolute embargo guarantees the exact outcome the U.S. is trying to avoid.
Oh, really?
Yeah, by completely cutting off the supply of all GPUs, you remove any incentive for Chinese tech firms to stay within the Western software ecosystem.
Because you leave them with absolutely no choice but to figure it out themselves.
Exactly. You'd force all that domestic capital, the research talent, the enterprise integration, you force all of it to align entirely behind local hardware.
Which means they build their own.
Right. The result would be rapidly maturing domestic chip fabrication, creating a fully independent parallel technology supply chain practically overnight.
Here's where it gets really interesting. Because an absolute ban backfires, the U.S. uses a totally counterintuitive strategy.
Yeah, that's why.
Instead of a complete ban, they play this deliberate game of controlled exports. They actually allow highly modified, performance-capped GPUs like the NVIDIA H200 to be sold under tariff premiums.
And this controlled export game achieves two crucial goals. The first is capital extraction.
Okay, walk us through that.
So, by leaving a tiny valve open and selling these capped chips at a premium, the U.S. basically drains domestic capital out of China.
So we are essentially forcing the Chinese market to fund the billions in next-generation R&D.
Yeah.
Like the Blackwell and Rubin architectures, the very stuff that keeps the U.S. ahead of them. That is a wild catch-22.
It really is. And the second goal is software lock-in. By ensuring those capped chips are still available, the U.S. keeps Chinese developers writing code in CUDA.
I see.
And as long as their code is written in CUDA, their entire software ecosystem remains tethered to Western hardware architecture.
It's like giving someone a slightly slower iPhone.
Exactly that.
Like, as long as they keep using iOS and buying apps from the App Store, they won't bother spending billions to build their own smartphone operating system from scratch.
Right. You keep them dependent.
So if you're listening to this and wondering why global tech strategies seem so convoluted lately, this tension is exactly why. It's a very fragile equilibrium.
It is. And this raises an important question. If AI models like K3 are already autonomously developing their own custom compilers to translate code for local chips,
Yeah.
how long can a human-designed strategy of software lock-in truly last?
Wow. Yeah, I mean, if the software is smart enough to seamlessly adapt itself to that custom homemade console, suddenly it doesn't matter who manufactured the hardware at all. Something to chew on as this global chess match continues. Thanks for joining us on this deep dive. Keep questioning the hardware you rely on.